Okay. Hello, students. This is Dr. Sumana, Department of Mechanical Engineering, Government Engineering College, Hassan. Today, I'm here to present a topic on design of temporary joints. The subject is design of machine elements for 5th semester mechanical engineering students. The subject code 18ME52. After after the module or the main objective of the subject is to understand the various steps involved in the design process, to explain the principles involved in design of machine elements, what are the different kinds of loads and forces to which the mechanical components are subjected, what are the design considerations with reference to strength, rigidity, functional and manufacturing requirements, to understand and interpret different failure modes and application of appropriate criteria for design of machine elements, to learn the use of national and international standards, okay, to develop the capability to design different elements or components like shaft, coupling, rivet joints, welded joints, temporary joints such as quarter joint, knuckle joint, power screws, etc. This presentation is with respect to temporary joints. Okay. So now, in the previous slide or in the previous presentation on temporary joints, we have seen what is a temporary joint. So here in this presentation, we'll be learning about design of knuckle joint, which is also a type of temporary joint. Knuckle joint is used to connect two rods subjected to axial tensile loads. It may also be used to support the compressive load if the joint is guided. But it is not suitable to connect rotating shafts which transmit torque. Axis of the shaft to be joined should lie in the same plane or may coincide or intersect. The construction of knuckle joint permits limited relative angular movement between the rods about the axis of the pin. Knuckle joint is widely used to connect wall rods, eccentric rods in the link of a cycle chain, levers, tie rods, etc. A knuckle joint has three main components. Okay, as shown in the figure, it is eye, fork, and pin. Okay. The eye is formed on one of the rods and the fork is formed on the other. The eye fits inside the fork and the pin is passed through both the fork and the eye. This pin is secured in its place or position by means of a split pin. The ends of the rods are made octagonal to some distance for better grip and are made square for some portion before it is forged to make the eye and the fork shapes. The advantages of knuckle joint are it is simple in design and manufacturing, relatively less number of parts, okay, hence the cost is less. It is simple to assemble and disassemble the components without damaging the assembling component. So coming to the design of knuckle joint, okay, as now for this design purpose or for the calculation of the parameters, I have referred Design Data Handbook by Dr. K. Lingaya, second edition. So with reference to design of knuckle joint, some of the standard notations used in the component of knuckle joint are F, load, D is the diameter of rod, D2, diameter of pin, D3, diameter of pin head, D4, outer diameter of eye, B, thickness of single eye, A, thickness of fork, H, thickness of pin head, sigma T permissible tensile stress, sigma C permissible or allowable crushing stress, tau allowable or permissible shear stress. Okay, so the stresses in Newton per mm square. Okay, so with reference to design of knuckle joint, the procedure given below can be followed to find out the dimensions of a knuckle joint by considering the various modes of failure. Okay. So here, equation 17.46 defines the tensile stress in the rod. Okay. So if you refer figure 17.9 in Design Data Handbook by K. Lingaya, second edition, it's a diagram with notations of knuckle joint or related to design of knuckle joint. Equation 17.46 defines the tensile stress in the rod. Equation 17.53 defines shear stress in the knuckle pin. Equation 17.51 compressive stress in the eye due to bearing pressure of the pin. Equation 17.48 shear stress in the eye. Equation 17.47 the tensile stress in the net area of the eye. Next we have equation 17.50 stress in the fork end due to tensile stress in the net area of the fork end defined by equation 17.47. 17.50 gives the stress in the fork end due to tear off. Okay. Tensile stress in the net area of the fork end defined by equation 14.49. Equation 17.52 defines the compressive stress in the fork due to bearing pressure of the pin. Now all this, okay, then we have the last two equations. The diameter, the head diameter of pin designated as D3 and the thickness of pin head designated by small h. So D3 is normally given by 1.5 times the diameter of rod, while the thickness of pin head designated as h is given by 0.5 times the diameter of the rod. So once we find out all these parameters required in a knuckle joint, we find out what is the maximum bending stress in the pin. So it is given by equation 17.55. Okay. So if the maximum bending stress or the stress induced in the pin is less than the allowable stresses, then we can say that the design is safe. Else the design has to be reviewed. Okay. So to discuss the theoretical, now we have discussed the theoretical aspects of design of knuckle joint. Okay. So solving one or two problems will make us understand the design aspects better. Okay. So let's come to a problem. Okay. Design a knuckle joint to connect two mild steel rods to sustain an axial pull of 150 kilonewton. The pin and the rods are made of same material. Assume the working stress in the material as 80 MPa in tension, 40 MPa in shear, and 120 MPa in crushing. So these are the parameters given for designing a knuckle joint. Now students, read the problem thoroughly and just write down the given data. So from the given problem, the given data is we have load F equals 150 kilonewton. Okay. T equals 80 MPa. Equals 40 MPa. And crushing sigma 1. Now based on the given data, let's find out design dimensions for different parts of knuckle joint. design of a. So if you come to the equation, so in the area